Hello and welcome to Chemistry with Dr. Clark. In this video, I'd like to talk about atomic number and mass number and how they relate to isotopes. So what I have here is a definition of atomic number. Your atomic number is the number of protons in the nucleus of your atom. Now, atoms have a lot of numbers associated with them. This would have to be one of the more important ones. The number of protons in the nucleus defines the atom. Let's do this. Let's say that you have an atom and that you shrank really tiny so that you could actually see the nucleus. And so when you looked at the nucleus, you saw that there were 6 protons. We like to use the P for proton, and we do like to put a little plus sign there because, well, it's a proton, it's positive. So you could shrink yourself down and you could see that there are 6 protons. The minute that you see that there are 6 protons in the nucleus, you automatically have carbon. Okay? 6 protons is defined as a carbon atom. If you look at the atom next door, and let's say the atom next door has 7 protons, that's not a carbon, right? In order to be a carbon, you have to have 6. If you have 7 protons, you're something different. You're a nitrogen. Okay? So these atomic numbers, the number of protons, basically tells you which atom you have. It's their identity. It's so important that that's how we arrange our periodic table. Now, I've only got a small piece of a periodic table here, but if you look at your periodic table, there's a number above each element, and that number represents the number of protons, right? Carbon has 6, so carbon has a 6 on top of it. Nitrogen has 7 protons, so there's a 7 above nitrogen. Now, normally we refer to these as just the element numbers, right? Phosphorus is element number 15. Chlorine is element number 17. But these numbers on the top represent the atomic numbers, the number of protons. And if you have the same number of protons as all your neighbors, then you're all the same element. Okay, let's talk about what else can be in my nucleus. Because, let's say that we'll do carbon. You've got 6 protons in your nucleus, and the neighbor has 6 protons. It turns out that your nucleus contains both protons and neutrons. So if we're going to talk about carbons, every single carbon has to have 6 protons, like all of them. But the number of neutrons can vary. Some carbons can have 6 neutrons in their nucleus. Some carbons can have 7 neutrons in their nucleus. Okay, your number of protons is fixed. It's like it can't change. But your number of neutrons can vary. Okay? It doesn't really affect a whole lot of the chemistry that you're going to do. Most chemistry is based on protons and electrons. Right? The neutrons doesn't really have an effect. So whether you have 6 or 7, both of these atoms would behave pretty much the same. Right? If you reacted them with oxygen, this would form carbon dioxide, this would form carbon dioxide. If you had a little brick of it, right, like a charcoal briquette for your barbecue, that's pretty much pure carbon. If you had this carbon or this carbon, they would still both burn. They'd both give you heat. The only time that it's going to be an issue, the only time that you have to be worried about the number of neutrons is when you're doing nuclear chemistry or atomic chemistry, okay? When you actually are talking about nuclear reactions. And that's just a very small branch of chemistry, and we don't usually see it. All right, so let's talk about our carbon. This carbon has 6 protons, it has 6 neutrons, and zipping around on the outside, there's 6 electrons. Because if you have a neutral atom, the number of negative electrons has got to match the number of positive protons. Neutrons are neutral, that's why I put a little 0 up here as its superscript. And so they don't really contribute to the charge. Right? But if you got a neutral atom, positive protons, negative electrons got to match. Well, for this one here, you may have 7 neutrons, but you still only have 6 protons. If you have 6 protons, that means you got to have 6 electrons zipping around the outside, right? So if you're talking carbon atoms, protons are the same, electrons are the same, neutrons can be different. Now let's talk about how heavy they are. If you had a little tiny scale, a little tiny balance, and you're going to measure how heavy they were, electrons are very, very light. Neutrons and protons are pretty heavy in comparison. Okay, let's say that an electron weighed 1, then a neutron would weigh 1,740, I believe. And a proton would weigh 1,740. Like, they're almost 2,000 times heavier. So if you wanted to talk about the number of things in this atom that are heavy, the protons are heavy, the neutrons are heavy, but the electrons are not. So when we talk about mass number, which is what we're getting to next, the mass number is going to be the number of protons plus neutrons. Because out of the 3 subatomic particles, only protons and neutrons are the heavy ones. And I'd like to know, if I were to weigh a carbon atom, where does most of the weight come from? Where does most of the mass come from? It comes from protons and neutrons. So it's important to be able to look at it and know how many protons and how many neutrons. Now, like I say, the protons are easy. Because if you look at your periodic table will tell you exactly how many protons, right? Argon is element 18, so it has 18 protons. The neutrons, though, are a bit more of a problem because an argon, while it always has 18 protons, doesn't always have the same number of neutrons, right? You can have a little more or a little less. So your mass number allows you to keep track of that. It's going to tell you the number of protons plus the number of neutrons. So let's say we do an example. If I told you that aluminum atoms have 14 neutrons, I could ask you, please tell me the atomic number and please tell me the mass number. Okay, so for aluminum, if you go to your periodic table, or our mini periodic table, aluminum is element number 13. Because it's element 13, it has 13 protons, and so its atomic number is 13. The minute I tell you the identity of the atom, then you should also be able to tell me the atomic number. Now for the mass number, you're going to have to work a little bit, right? Because mass number is protons plus neutrons. Okay, protons, you know, is 13. And like I say, the neutrons can kind of vary. So if I want you to be able to do this kind of calculation, then I'm going to have to give you some indication of how many neutrons there are. Right? I have to tell you that this particular aluminum atom has 14 neutrons. Because the next aluminum atom may or may not have 14 neutrons, right? It could be different. So if you're going to talk about these sorts of problems, you're going to have to be given some information about neutrons. So 13 plus 14 is 27. So my mass number is 27. My atomic number is 13. Now this is probably also a good time to talk about names and symbols. If you're doing chemistry and you really don't care how many neutrons you got, we would just call this aluminum. Right? It'd just be plain old aluminum, and the symbol would be Al. But if you are concerned about the number of neutrons, then you have to give me some information. You've got to give me some clue as to what's happening inside that nucleus. So what we like to do is we like to modify the name. So we like to keep the original name, but we like to write the mass number at the end. So because the mass number here is 27, if neutrons are important to me, then I won't call this just aluminum. I'll call it aluminum 27. Because that'll give me some information about how many neutrons I have. Same thing with the symbol. Normally, aluminum just has the symbol Al. But if you're concerned about how many neutrons and how many protons, then we need an enhanced symbol. We need something extra. So what we've decided is that we're going to put like a subscript and a superscript out in front. The subscript is going to be the atomic number, And the superscript is going to be the mass number. Okay, so the atomic number for aluminum, 13. Maybe we switch colors. Okay, so let's put a 13 here. The mass number is 27, so the 27 will go on the top. So this is aluminum 1327. Atomic number 13, mass number 27. Okay, if you're talking about neutrons and they're important to you, then you have to have an enhanced symbol. You can't just have aluminum. You need to have the aluminum with the 13 and the 27 out in front. Now, before we move on to the next topic, we should also note that mass numbers are often referred to as atomic mass numbers. And when I say often, I really should say sometimes. And when I say sometimes, I should really say almost never. Okay, so sometimes, almost never, you call it atomic mass number, but the majority of textbooks, the majority of worksheets and things will just call it mass number. These two numbers have symbols. Atomic number has the symbol Z. The mass number has the symbol A. And when I think about this, it's not intuitive, right? Atomic number starts with an A, but its symbol is Z. Mass number, none of them start with an A, but yet its symbol is A, right? For me, the symbols are not intuitive here. So if you do have to know the symbols, you're going to have to sit down and memorize them. All right. Now, let's talk about the branch of chemistry that actually cares about neutrons. It would be when we were studying isotopes. Isotope is when you have more than one atom. They're all the same elements, so they all have the same atomic number, but they all have different mass numbers, okay, because they all have different numbers of neutrons. So maybe we should draw a little picture of that too. Hydrogen is a good example of this, because if you're talking hydrogen, hydrogen is element 1. So if you have a hydrogen that has one proton, one proton, one proton. But when it comes to neutrons, hydrogens can have 3 different varieties. Some hydrogens have no neutrons, like 0, none. Some hydrogens will have 1 neutron, and some hydrogens will have 2. So 1 neutron and another neutron. Okay, so you can have no neutrons, 1 neutron, or 2 neutrons. Because they're hydrogens, they all have 1 proton. So for these here, if we're talking mass number versus atomic number, the atomic numbers are the same. 1 proton, 1 proton, 1 proton. But your mass numbers are different, right? Mass numbers are protons plus neutrons. So 1 proton plus 2 neutrons, 3. 1 proton plus 1 neutron, 2. And 1 proton plus no neutrons is 1. Okay? This is a hydrogen, this is a hydrogen, and this is a hydrogen. Right? Atomic numbers at the bottom, mass numbers at the top. This is like 3 different flavors of hydrogen. You can have hydrogen with 2 neutrons, hydrogen with 1 neutron, or hydrogen with none. And if you have more than one flavor of an element, we like to call those isotopes. Okay, isotopes. So I got a couple of examples here. Let's work our way through those. It turns out that if you have carbon, some carbons have 6 neutrons, some have 7, and some have 8. So there are 3 different flavors or 3 different types of a carbon atom. So let's label them. Let's call the first one isotope A. Let's call the second one isotope B. And let's call the third one isotope C. And what I'd like to talk about is atomic number, and I would like to talk about mass number. Now, they're all carbon atoms, right? So if they're all carbons, here on my little periodic table, carbon is element 6. They all have 6 protons. So the atomic number for the first one is 6, the atomic number for the second one is 6, and the atomic number for the third one is also 6. Right? If you're carbon, they're all element 6, so they all have 6 protons. Their atomic numbers are 6. But the mass numbers will be different because it's protons plus neutrons. Protons plus neutrons and protons plus neutrons. The first isotope has 6 neutrons. I had to tell you that. The second isotope has 7 neutrons. Had to tell you that. And the last isotope has 8 neutrons. And again, I had to tell that to you. Right? There is really no way for you to make a guess at how many neutrons you have. Someone needs to tell you. So 6 plus 6 is 12, 6 plus 7 is 13, and 6 plus 8 is 14. So if we name these things, this would be a carbon-12 because its mass number is 12. This would be a carbon-13, and this would be a carbon-14. Now, the carbon-13 you've probably heard from or of before. When they find really old things, you have an archaeologist, they're out digging somewhere in the forest and they unearth something tremendously old and they want to know how old it is. They'll talk about doing carbon-13 dating. It's all about measuring how many of this type of carbon is in the sample. Right? This is the one that they are looking at specifically. All right, let's move on to nitrogen. Nitrogens can have either 7 or 8 neutrons. So again, let's call this isotope A. And let's call this one isotope B. Now, at the end, I'd like to write the symbol, right? I don't want to write the name. I'd like to write the symbol of this. So I'm going to be smart/sneaky. I'm going to talk about mass number first, and I'm going to talk atomic number second. Because when I write the symbol, the mass number is always in the superscript, the atomic number is always in the subscript. So I'll have them written so that I can just put the symbol for the element in, and I will have magically created the symbol for the isotope. Okay, but let's do atomic first. Even though I listed it second, let's do it first. So if we're talking about nitrogen, nitrogen is element number 7. So my atomic number for both of these will be 7s because they're both nitrogen. In order to find my mass number is atomic number plus your number of neutrons, right? Number of protons plus neutrons. So the first isotope has 7 neutrons. 7 plus 7 is 14, so my mass number is 14. The second isotope has 8 neutrons, so 7 plus 8 is 15. And if I want to turn these into the symbols, the symbol for nitrogen is N. So this would be nitrogen 714, and this would be nitrogen 715. Atomic number on the bottom, mass number on the top. Now, for a particular question about isotopes, we could ask it like this, right? We could just tell you the atom, tell you the neutrons, and ask for atomic number, mass number, the name, the symbol, something like that. What's more likely to happen, though, is that it'll be given to you as a table. Okay, so this table asks for the name of the element, the symbol, number of protons, number of neutrons, atomic number, and mass number. Okay, so it asks for everything. And what it gives you is kind of a mixture of odds and ends, right? They give you some things and they ask for a lot more. Well, this table is actually quite easy if you remember the relationships, right? The number of protons and the atomic number are the same. So if you know that you have 2 protons, then you know that you have an atomic number of 2. If you know that you have an atomic number of 2, then you know the number of protons are 2, right? Those 2 columns are identical, but you have to remember that relationship. Protons and atomic number is the same thing. It's just 2 different names for the same thing. The other thing that you need to remember is that if you take the number of protons, add it to the number of neutrons, you get your mass number. So if I know the number of protons and I know the number of neutrons, then I can add them together to get my mass number. 2 plus 1 is 3. Right? If you know your number of protons and you know your number of neutrons, you can add them together. 2 plus 2 gives me 4. Now, I did all of this, and I really haven't identified my element yet. Right? I know the protons, I know the neutrons, but I haven't really identified what is the element. So, number of protons is 2. That means this is element number 2. If we're talking element number 2, that's a helium. So this would be helium. Now we do run into a small issue. See how the number of protons in the first row is 2, so the first row has element helium? Well, the second row also has 2 protons, so the second element is also helium. But there's differences, right? They may have the same number of protons, but they have different numbers of neutrons. So if you have different information about the 2 heliums, you have to tell me that they're different, right? So this would be helium, mass number 3. This would be helium, mass number 4. And if we do our symbol for helium is He, symbol for helium is He. And again, because I have slightly different information for the 2, I need to have slightly different symbols. So the atomic number for both is 2. So a little subscript 2. The mass numbers, though, are different. So this superscript would be a 3, because this is helium 3. This superscript would be 4, because that's a helium 4. All right, let's talk about the next one. The next one gives me a symbol and some numbers. Let's use our numbers. We know that the number at the bottom is your atomic number. So the atomic number is 4. We know that the number up here in the top, the superscript, that's my mass number, so that would be a 9. Now if we use our relationships, if you know the atomic number, then you automatically know the number of protons, 4. Now let's talk about that addition thing. We had said that if you know the number of protons and you know the number of neutrons, then you can tell me the mass number. And up until this point, we've been adding, right? 2 plus 1 is 3, 2 plus 2 is 4. This one, though, is a little different, right? I'm not asking for the sum, I'm asking for the missing piece. So this is really more of a subtraction, right? Think of it in terms of math. If I had 4 plus x equals 9, right? 4 plus an unknown is 9. Let's call it x. If you want to move 4 to the other side, you'd subtract 4 off both. So 4 minus 4 is gone. 9 minus 4 is 5, right? This is just a little math equation. 4 plus 5 is 9. 9 minus 4 gives me 5. And if we write the name for this thing, Be stands for beryllium. B-E-R-L-L, whoops, beryllium. And I believe that I may have forgotten my Y. Yep, beryllium with a little Y right here. We don't use beryllium a whole lot, and it's one that I always have trouble spelling. Now, we should talk about spelling these things. You do have a periodic table, so if you do have trouble spelling any of them, make sure you look them up, right? Because you should have some high-quality work here, right? And you don't want to be misspelling your elements. For me personally, beryllium is like, it's the one that always messes me up, so I always have to be careful of it. The other thing I should mention, when you write the name of an element, it's not like your name, right? So it doesn't get a capital letter. That's why I have lowercase h's for the helium and a lowercase b for the beryllium. All right, let's move on to oxygen. This is oxygen 17. Ooh, I forgot to finish this one. You have to put your mass number at the end. Mass number is 9, so this is beryllium 9. Ooh, I almost messed that one up twice. Forgot the Y and forgot the mass number. All right, let's talk about oxygen 17 now. The 17 at the end is your mass number, 17. Now, I need to know protons or I need to know atomic number, but this doesn't tell me either one. Except it does. Chemistry can be pretty sneaky. The minute I told you that this was oxygen, I was also secretly telling you the number of protons, right? Oxygen is element 8, so it would have 8 protons and therefore an atomic number of 8. Okay? You got to be careful. Sometimes chemistry is sneaky. So again, number of protons plus the number of neutrons gives me the mass number. So 8 plus something is 17. If you want to figure out what it is, you move the 8 to the other side of subtraction. So 17 minus 8 gives me 9. And you can check that, right? 8 plus 9 is 17. If we do the symbol for oxygen is O. My atomic number is 8. My mass number is 17. All right, if we kind of breeze through the rest, the atomic number is 18, so the protons would be 18. 18 plus something gives me 40, right? If you got 18 protons and an unknown number of neutrons and they have to add up to be 40, then that would mean you have 22 of these. And if you have 18 protons, that's telling you that you have element number 18. So that's saying that you have argon. So it is argon, and the mass number is 40. The symbol for argon is Ar. It has an atomic number of 18. It has a mass number of 40. And if we do the very last one, if you have 16 protons, then your atomic number is 16. 16 protons plus an unknown number of neutrons gives you a 36 total, right? Your mass number is the total. So 36 minus 16 gives me 20. And then I can write my name and my symbol. If you've got 16 protons, then you are element number 16 right here. So that's a sulfur. Dash the mass number, which is 36. Symbol for sulfur is an S. Atomic number is 16. Mass number is 36. This sort of table is one of the favorite ways for asking this question because we can ask you to do a lot of relationships in a very small space. Now, the next video in the series, we'll talk about mass numbers versus atomic mass. Okay, your mass number, which is what we talked about here, is the number of protons plus neutrons. Okay, your atomic mass, no word number at the end, is talking about how heavy an atom or an isotope is. Okay, it's different. So if you are having to deal with mass numbers versus atomic masses, please check out the next video in the series. And as always, thank you for joining me here at Chemistry with Dr. Clark.